Germany's best engineers just watched a Chinese saloon do something their entire industry cannot explain. No hydraulics, no mechanical delay, electromagnetic suspension reacting 10 times faster than anything Stuttgart has ever built. The price? Less than a BMW 5 Series. For 2 years, Europe called this China's problem, a domestic experiment, something safely contained behind a firewall. That firewall just collapsed. The Yangwang U7 is going global, and by the end of this video, you will understand exactly why nobody in Munich, Stuttgart, or Coventry has a single answer for what comes next. To understand why this machine is genuinely terrifying to the European establishment, you have to start with a number that makes no rational sense. For generations, the performance hierarchy in the luxury saloon segment was simple. If you wanted 4 doors and over 600 horsepower, you were looking at the Mercedes-AMG S63, the BMW M5, the Porsche Panamera Turbo, exceptional machines. Also machines that cost north of £120,000 before a single option is added. If you wanted to breach 1,000 horsepower in a road-legal saloon, the numbers became almost absurd. Bespoke commissions, hypercar territory, prices that cross £250,000 without blinking. The Yangwang U7 produces over 300 horsepower. Its home market launch price sits at the equivalent of approximately £70,000. Read that again slowly. £70,000 for a machine that outpowers the Bugatti Chiron in raw output, rides with the composure of a Rolls-Royce, and runs on technology most European brands haven't even committed to a development roadmap for yet. How is this possible? The answer is vertical integration at a scale the Western automotive industry has never seen. The parent company behind the Yangwang brand manufactures its own battery cells, its own microchips, its own electric motors, and its own power electronics. Every component that a European brand sources from a global supply chain at enormous markup, BYD produces in-house and at massive volume. The result is a cost structure that makes traditional luxury pricing look like a protected racket. When this car lands in international showrooms, it will not just compete with the European elite, it will expose them. Here is where the engineering story becomes genuinely remarkable, and where a critical misconception needs to be cleared up. When most people first encounter the Yangwang lineup, they conflate the U7 Saloon with its more theatrical sibling, the U9 hypercar. The U9 made headlines globally for its ability to bounce on the spot, lift individual wheels, and perform hydraulic acrobatics that looked more like a carnival act than automotive engineering. That system, known as D-SUS X, relies on high-pressure active hydraulics to perform those dramatic maneuvers. The U7 uses something completely different, something arguably more significant. BYD's engineers developed an entirely new suspension architecture for this car called D-SUS Z. And the fundamental difference is this: it eliminates hydraulics entirely. Traditional suspension systems, even the most advanced air-sprung, electronically controlled setups found in a Bentley Flying Spur or a Mercedes S-Class, still rely on physical fluids moving through valves or compressed air shifting through rubber chambers. These are mechanical processes. They take time. Even the fastest conventional system requires between 50 and 100 milliseconds to respond to a road input. In the context of driving physics, that delay matters enormously. D-SUS Z replaces every conventional damper on the vehicle with a linear electromagnetic motor mounted directly to each wheel assembly. There are 4 of them, 1 per corner, and they operate on pure electromagnetic force. No fluid, no air, no mechanical intermediary between the sensor reading the road and the force being applied to the wheel. The response time is 10 milliseconds. That is 5 to 10 times faster than any hydraulic system in production today. But the engineering achievement goes deeper than speed. When a conventional damper absorbs a bump, that kinetic energy is converted to heat inside the damper fluid, and it disappears, wasted, gone. In the D-SUS Z system, when a wheel is pushed upward by road irregularity, that vertical motion drives the linear motor backward. The motor becomes a generator. That energy, the energy of hitting a pothole, of crossing a rough surface, of every imperfection in the road, is captured and fed back into the main battery pack. The rougher the road, the more energy the suspension harvests. It is a closed-loop energy system built into the chassis itself, and it is unlike anything currently offered by any European manufacturer at any price point. The U7's global version introduces a plug-in hybrid powertrain alongside its fully electric variant, and this is where the packaging story becomes one of the most interesting engineering puzzles in recent automotive history. The car's drag coefficient is 0.195 CD. To put that in perspective, the Porsche Taycan, one of the most aerodynamically developed production saloons in Europe, achieves 0.3 CD. The U7 is measurably more slippery through the air than some of the best engineering in Germany has managed. That extraordinary number is made possible by a dramatically low bonnet line, a tapering, sculpted nose that sits closer to the ground than most sports cars. Now add a 2.0-liter turbocharged combustion engine to that equation. Conventional engine architecture, whether inline-4 or V configuration, requires substantial vertical clearance for pistons, crankshafts, and overhead camshafts. There is simply no way to fit a standard engine block under a bonnet that low. BYD's answer was to design a horizontally opposed, ultra-flat engine block paired with a dry sump lubrication system. The entire combustion unit sits nearly flat within the lowest section of the engine bay, with a total powertrain height of just 420 mm. For reference, a standard 4-cylinder engine block typically requires over 600 mm of vertical clearance. They effectively invented a new engine architecture to solve an aerodynamic problem, and the solution serves the physics of the car twice over, because an engine sitting that low contributes directly to center of gravity. Then there is the battery. The 135 5 kWh pack developed for this platform weighs 930 kilograms, and it accounts for exactly 1/3 of the car's total curb weight. By positioning that mass completely below the floorline, combined with the flat-mounted combustion engine near the base of the engine bay, the U7 achieves a center of gravity lower than virtually any petrol-powered performance saloon currently on sale, lower than a Porsche 911, lower than an M5, lower than cars designed from the ground up as performance machines without the constraint of a luxury cabin above them. And the charging system that feeds this pack? BYD claims full recharge capability in under 5 minutes using their latest ultra-rapid charging architecture, made possible by redesigned internal bus bars featuring aerospace-grade liquid cooling channels capable of managing extreme energy density without triggering thermal instability. That specification, if proven consistently in real-world conditions, would make range anxiety effectively obsolete. Numbers and specifications are one thing, real-world application is another. So consider the following scenario. You are traveling at 70 miles per hour on a wet motorway at night. A front tire suffers a catastrophic blowout. In a conventional vehicle, regardless of how sophisticated its electronics, the sudden asymmetric drag and loss of corner support will violently pull the steering. The reaction time required to correct it is measured in tenths of a second. For most drivers, that is not enough. In the U7, the sequence unfolds differently. The inertial measurement units monitoring the chassis detect the microscopic change in roll angle before the driver's nervous system has processed the sound of the explosion. In the same moment, the linear electromagnetic motor at the damaged corner fires downward, acting as an active structural support, holding the wheel assembly at ride height, preventing the brake rotor from ever contacting the road surface. Simultaneously, the E4 quad-motor platform redistributes torque across the 3 remaining wheels to maintain straight-line tracking. The car continues traveling down the motorway, stably, safely, under control. This is not a theoretical emergency mode. It is the direct consequence of having 4 independent motors, electromagnetic suspension with a 10 millisecond response loop, and a chassis computing architecture that operates faster than human perception. The safety technology is not a feature list. It is the natural output of the engineering architecture itself. For decades, European automotive prestige was sold as a formula only history could produce. The argument was simple. Trust us, because we have been doing this for 100 years and nobody else understands the recipe. Buyers paid the premium. The industry thrived on that logic. The Yangwang U7 does not argue with that history. It simply makes it irrelevant. Electromagnetic suspension that harvests road energy, quad-motor torque vectoring measured in milliseconds, an engine architecture designed from scratch to solve an aerodynamic equation, a battery system that recharges in 5 minutes. All of it at a price that undercuts the German establishment by a factor of 2 or more. The question is no longer whether global consumers will consider a Chinese luxury saloon. That debate is already over. The real question, the one being asked in every product planning meeting from Stuttgart to Coventry right now, is how much time is left before the answer becomes visible on every high street in Europe. The electromagnetic era of the automobile has arrived, and it did not ask permission.